Hello and welcome to section 2. This is a section about absolute value functions and translations. So what we want to do is talk about the concept of absolute value. We've discussed this so far, but the absolute value of a number, so absolute value of, let me write this over here. Absolute value, remember, means distance from zero, okay? Distance from zero. Okay, and remember what we have is if we have a number line and we say, okay, well, here's 0, here's positive 2, here's negative 2, okay? So if I wanted to say, all right, what's the absolute value of 2? Okay, what's the distance from 0 to 2? Okay, and that would be a value of 2. Okay, similarly, what's the distance from negative 2 to 0? Okay, what's that distance? So if I wanted to say what's the absolute value of negative 2, then that would give me a value of 2. Okay, so what happens is that anything inside the absolute value symbol, I'm going to write that, anything inside of the absolute value symbol is positive. Okay, and the reason is because distance is positive, okay? But that's the idea. All right, so what I want to do is consider the function, okay, the absolute value function. Okay, so if I have f of x is equal to absolute value of x, another way of writing that would be saying y equals the absolute value of x. Okay, and so when we have this thing called the parent function, okay, and that is the simplest function in the family of functions. So the parent function for an absolute value function is just the simple y equals absolute value of x. Okay, so if I were to plug in these different x values, okay, into my function here, so plug in negative 2 into here, and let me do that real quick. So let me do, the absolute value of negative 2, that's going to give me a value of 2, okay? If I did the absolute value of negative 1, okay, take that, the distance from negative 1 to 0 is just going to be 1. Okay, the absolute value of 0 is just going to give me 0. And then the absolute value of 1 is just going to give me 1. The absolute value of 2 is going to give me 2. So if I were to go through and plot these points, okay, what you end up getting here is the point negative 2, 2. So I'm going to plot that point here, negative 2, 2. This is the point negative 1, 1. So that's going to be here. And then the point 0, 0, which is going to give me this point here. Then you have 1, 1, which is here. And then the point 2, 2, okay, which is here. And you get this V-shaped graph. Okay, let me redraw that so it fits all the points, right? Okay. And that's what you get. Okay, if we also wanted to talk about this, and this is the simplest graph, okay, so an absolute value symbol or absolute value graph is just going to have a V-shaped graph like this, all right, but we can also define f of x equals the absolute value of x in another way. Okay, we can define it as a piecewise function, and we can say f of x is equal to this, okay, and this graph here is the graph negative x, okay? And that exists when x is less than 0, okay? And then this graph here is the graph positive x, okay? Slope of 1, y-intercept is 0, and this is positive x, and that exists when x is greater than or equal to 0. Okay, so an absolute value function can be defined either way, okay? You can say, all right, well, here's, here we're going to, we can write it like this or we can write it as a piecewise. Doesn't really matter, okay? So let's quickly talk about vertical translations. Vertical translation means that if you have, some function g of x is equal to the absolute value of x plus k, then the graph is going to be translated vertically. Now, when I say vertical translations, that means that we move the graph up or down. So move the graph up or down. Okay? And so we have that if k is positive, then the graph is moved up that number of units. Okay? If k is negative, then the graph is moved down that unit. So when we have a vertical translations, when we move the graph up or down, okay, that means that we add or subtract a number. So I'm going to write this. Add or subtract a number outside of the absolute value symbol. Outside of the absolute value symbol. Okay? So what you notice is that you have all these different examples. You have, if you have f of x is equal to the absolute value of x, here is your parent function, okay? And then if I were to say, okay, well now what's the absolute value of x plus 5? And so what we've done here is we've taken all these points, okay, that you had, which were, the points 0, 0, 1, 1, 2, 2, and what you've done is you've moved them up 5 units, okay, to here. Taken all these points and just moved them up 5 units, okay? And so that value, these are 5 units, okay? And then you just move it up, okay? Same thing over here. If you had a different function, say p of x equals the absolute value of x minus 3, okay, then what you would think about is you would take, all these points and move them down 3 units. Okay, each distance from here to here, those are all 3 units. Okay, and that's the idea, all right? So it's not too terrible. So what I want to do is, let's go ahead and just graph the function. F of x is equal to absolute value of x minus 6. So because you have a minus 6 here, this is going to move the graph down 6 units. Okay? So what I want to do is come over here and say, okay, I have the point 0, 0. All right, I'm going to move that point down 6 units, okay? And this goes by 2, 4, 6. So it's going to start giving me right there, okay? This point here needs to be moved down 6 units. So I'm going to plot a point here, here, here. And so it just follows that natural progression. Same thing here. You're going to have a V. But all these points are just moved down 6 units. We just want to connect those dots. Okay? And that's all we're doing. Okay? All right, let's take a look at so writing this function represented by this graph. So what I want to do is write this a couple different ways. I want to first write it using the absolute value method, and then I want to use a piecewise defined function. So what I have, I'm going to draw my parent function here. All right, make it look nice and purty. All right. This is the function y equals the absolute value of x. Okay, now what I want to think about is, okay, well, where did this go? How did I go from here, from my parent function, down to here? Okay, and the distance from this bottom of the v to this point here, this has a value of -7. So what I've done is this has been shifted down 7 units. Okay? And so from there, what I want to do is I want to write this as, and you can write it as f of x. We use f of x is equal to the absolute value of x minus 7. Okay? And that's it. Okay, now if I wanted to define this as a piecewise function, okay, I know if I were to look here, from this graph, I know my slope is equal to -1, and my y-intercept is equal to -7. So this part of the equation would be y equals -x minus 7, okay? And then this graph over here has a slope of +1 and a y-intercept of -7. So if I wanted to write the equation of this one, then I would write it as y equals x minus 7. Okay? But now we have to think about where do these exist. Okay? And if I wanted to write this function, instead of writing it as a piecewise, or as an absolute value, you can write it as a piecewise. And so I would say that this is going to be negative x minus 7, and that's over the interval for when x is less than 0. Okay? And this one over here is going to be x is positive minus 7, and that exists when x is greater than or equal to 0. Now you can change either one of these. They don't have to, as long as one of them is greater than or equal to, that's all that really matters. Okay? So either way you do it, either way you skin that cat. Okay? So now the other thing is we have horizontal translations. And this is when you move a graph either to the left or to the right. So we move left or right, okay? Now this one is a little weird. This one is backwards. So I'm going to write that in big, bold words, and this is backwards from the other one, okay? Now the other one we just followed the sign, okay? But the difference is that when you have this graph, okay, g of x is equal to the absolute value of x minus h, okay, is the graph of f of x equals the absolute value of x translated horizontally, okay? So now it says, you have to think about this. It says if h is positive, you're going to move it to the right, h units. If h is negative, then you're going to move it to the left, okay? So let's talk about this whole thing where we move h to the right. Okay, so let's do this. Let's let h equal 4. Okay, so if I were to write this and say, what is that? P of x? Okay, let's say that we have a function p of x is equal to the absolute value of x then minus 4, okay? Because if h is 4, then I plug it into this here, okay? But even though it says negative 4, then that means that we move it to the right 4. This is what's backwards, okay? And that's the issue that we're dealing with, okay? Now, if I come in here and say, well, let's let h equal negative 1, okay, and plug it into that other function, that's h of x. So let's have the function h of x be the absolute value of x minus a negative 1. Then really what that becomes is we get the absolute value of x plus 1, and so this means that we move it to the left 1. Okay, so it's kind of weird. It's backwards, okay? And you can see that when you graph these, okay, if you have x plus 1, we do the opposite. We go left 1 unit and move everything to the left. Okay, if you have p of x equals the absolute value of x minus 4, the negative 4 indicates I'm going to move it 4 units to the right. Okay, which is kind of weird, all right? So let's take a look at something over here. Okay, if you have, your parent function here is just the absolute value of x, but if I wanted to graph f of x is equal to the absolute value, and let me change my color here, and let me do that f of x is equal to absolute value of x plus 8. Okay, the plus 8 indicates that we move 8 units left. Okay, and so what I would do is I'd come over here and I would take my vertex, which is this bottom point here, and I would move it over to negative 8. And I would redraw my graph just as I had the other way. Okay, and that's it. All right, so it's a little bit weird, not too hard. Once you get used to this stuff, it's actually really easy. It's just, getting to that point is kind of tricky. Okay, so then let's take a look over here. All right, let's write a function represented by this graph. So I'm not going to do the piecewise, I'm just going to do the absolute value. And so if I draw my ordinary absolute value graph, okay, like so, what I notice is that, this is negative 1, negative 2, negative 3, negative 4, negative 5. This is halfway between negative 5 and negative 4. So this has been shifted left 4.5 units. Okay, so if I were to write my equation, and I would say I'm going to call this f of x is equal to the absolute value of x plus 4.5, okay, because it's plus 4.5, that indicates that it's been shifted left 4.5 units. Okay, so really not too bad. Hopefully it makes sense to you. All right, so let's talk about vertical and horizontal translations. And they kind of talked about, you know, all this different crap here. Okay, but you have this general form here, which has this, you know, if you graph g of x is equal to x minus h plus k, okay, this is going to be your shift left or right. Okay, and then the k is up or down. Okay, the left or right is backwards from the sign, and then up or down follows the sign. Okay. All right, so what I want to do is talk about this equation here. Okay, so if you have the absolute value, this function g of x, let me rewrite it, g of x is equal to the absolute value of x plus 2 and then minus 5. Let me make that more prominent. Then what I have is that this is a shift left 2 units, okay, and this is a shift down 5 units. So down 5 units, okay? So what I want to do is take this point here, okay, my vertex, move that to the left 2 and then down 5, and I'm going to plot a new point down here. Okay, and then I'm just going to continue to draw that same graph that I had. All right, and that's it. Kind of nice, ain't it? Yeah, pretty good, ain't it? All right, and that's the idea. All right, so the next thing I want to do is I want to identify the range of an absolute value function. Okay, my domain is all real numbers. Okay, I'm going to go from negative infinity to positive infinity. But this, what I notice is that we have been shifted down 8 units. So my range indicates that values that are going to be larger than or equal to negative 8. So I'm going to say that y is greater than or equal to negative 8. Okay, and that's it. All right, so we just got to be able to look at the graph. Where do you start? And where do you end, okay? Writing a function represented by the graph. So I want to take this point over here, and what I notice about this is that, and let's take a look, I want to identify my vertex, okay? And this is going to be the point negative 5, negative 6, okay? So what this means is that I have been shifted left 5 units, okay, and we've been shifted down 6 units, okay? So what we have is we have this, you know, if I just said, okay, let's call this g of x is equal to the absolute value. Now, if we go left 5 units, that means I have to do plus 5, so it's going to be absolute value of x plus 5, and then down 6 units means I'm going to subtract 6 on the outside, okay? So that's the idea, all right? So I hope you guys enjoyed this video. I hope you know, this makes sense to you. It's not too terrible, but we do have to make sure we watch the video and understand you know, how these equations are written and how they're made. So enjoy. Talk to you later. See ya. Bye.